Hi, we're going to use implicit differentiation to take the derivative in this case. This is a complex equation that has y intermixed with x and y embedded into functions like sine. So it's virtually impossible, or very difficult anyway, to solve this for y. If we could somehow or another solve it for y equals some function of x, we could use our regular derivative rules, but this is really complicated, so not only does the problem ask us to do it this way, but it's probably the easiest way anyway when you have a situation like this. So to do this, we're going to apply the derivative operator to both sides of the equation. And if you'll notice here that on the left side of the equation, I have two things that are both products. I've got x times sine y, and I've got y times sine x. So we're going to need to use the product rule, which I put up here on the upper right, so you have it as a reference. To take the derivative of x times sine y, we're going to treat the x as the u and the sine y as the v. So the derivative of that is equal to the derivative of x, which is 1, times sine y, which is essentially just sine y, but I'll put the 1 there, plus the derivative, plus x times the derivative of sine y. And we have to be a little careful here because derivative of sine is cosine, but remember that when I also have to take the derivative of what's inside if it's not just x. Right? I'm taking this with respect to x, and if what's inside of this function is not just x, I need to take the derivative of this. That's what the chain rule tells me. Well, the derivative of y is dy dx. So I need to multiply by dy dx. We don't really know what y is, right? Y was this complicated function that we can't really separate out, but we can say that the derivative of y is dy dx, and that's the way we do it. Okay, and then we repeat this on the second half. So we've got y is the u and v is the sine x, so we do the same thing. The derivative of y is dy dx times v, which is sine x, plus the derivative of, plus y times the derivative of sine x, which the derivative of sine is cosine, and I don't need to worry about the chain rule because I just have an x on the inside of it. And then I take the derivative of the opposite side, which is, it's just a constant, so that's just going to be 0. So I've got this big old long thing here. I'm going to erase this 1, by the way. And what I want to do, I eventually want to get to the point where it says dy dx equals something. So that means I want to separate out all the dy dx elements on one side of the equation and put everything else on the other side. So I've got these two expressions here that are both have dy dx in them, and so I'm going to just copy those down here so we've got those, and that's going to be equal to see what I had copied here on the other, so I'm going to subtract the other things and put those on the other side. So minus sine y and minus y cosine x. The reason I do this is I'm trying to gather all the dy dx's together, and now I can actually factor out dy dx here. So dy dx factored out would give me on the inside of the parentheses x times cosine y and plus sine x is equal to all this on the other side. And then I have this if this is just one big old long thing here of that blob, I can divide both sides of the equation by that blob. So I'm going to do that. When I divide by it, it essentially moves it over here. And so it leaves me with dy dx equals this fairly complicated thing here, but I don't see any way of simplifying this. There's nothing to factor out here that I can see. So that's going to be the derivative.